Good evening, everyone. On behalf of IEEE Computer Society chapter of Marathwada Mitra Mandal Institute of Technology, IEEE Student Branch, I warmly welcome all of the distinguished guests, faculty members, industry professionals, research scholars, and students joining us today. We are delighted to host the online international hands-on expert session on building AI agent. This session is organized under the joint chapter of IEEE Technology and Engineering Management Society and IEEE System Council's IEEE Pune section. Great pleasure to introduce our esteemed speaker for today. We are honored to have you, Mayuresh Waykole, sir, with us. Mr. Mayuresh Waykole serves as a senior software engineer at Microsoft Corporation and two strategically important areas of the company's engineering portfolio. He contributes to the synthetic monitoring systems that safeguard the reliability and availability of Microsoft Office 365 and Copilot services relied upon hundreds of millions of users across the globe. He also works on the resource provisioning platform that underpins Microsoft's offline evaluation infrastructure for Copilot, the systems through which Microsoft rigorously tests, measures, and refines its artificial intelligence agents prior to their deployment to end users. His work cites the convergence of large-scale cloud infrastructure and artificial intelligence evaluation, a vantage point that uniquely qualifies him to speak not only on how AI agents are built, but on the engineering discipline required to build them responsibly and at scale. Tonight, he will be guiding us hands on through building our very own AI agent from scratch and sharing his perspective on how each one of us can thrive as developers in AI first world. Without further delay, I would like to invite Mr. Mayuresh Waykore to take over the session and share his valuable insight. Sir, the stage is yours. Thank you.
Thank you so much, Mathili, and just welcome everyone. And thank you so much for your patience.
Thank you so
So
much for your patience, sir, and thanks to all the participants for being patient.
yes, and I think now give me a second. Let me see if I can share my screen. Um, all right. Can can all of you see my screen?
Yes.
Yes,
Okay.
sir.
So I know our original session was 60 minutes, but I'm going to cut short a little bit, see if we can wrap up things sooner than later. So anyway, yeah. Essentially, I think today my goal is to cover three things. The first one being help everyone kind of get an understanding of what AI agents are and what does an AI agent look like in practice. And second is, I know, I assume most of your students at universities, so there's a pretty there's a lot of fear mongering happening in the industry right now about the effects of AI and how it can be extremely detrimental for jobs and other things, right? So I think that's also it's one of my goals to address that as well, probably towards the end of the session. So all right. Um, so yeah, tonight we'll build a real AI agent, understand the agentic loop. This loop in the industry we call it the React loop, meaning you have some reasoning and then you take some action. So it's re for reasoning and then act for action. It's called a React loop. And today, although I know my slide says we are going to use zero frameworks, but that's not true. We are going to use one specific framework, which is the Google's Gen AI framework. And the only reason we are using that is because it makes it very easy to call the LLM APIs. But we're actually building everything else on top of that framework, right? We are not really using any of the inbuilt methods that are provided. Very few of the methods are being used, and you'll have access to all the code, everything else. You'll have your own API keys. So hopefully, this would be a great start for your experimentation with building agentic or AI-enabled products. Now, before we start, how do you thrive in an AI first world, right? So I'm just going to give you three quick mantras, and then we'll deep dive into building agents. Um, and these mantras will make more sense once you actually start building upon it. So the first one is be the orchestrator and not the typist. Meaning, typing code is not really a challenge anymore, right? As many of you have probably used ChatGPT, Gemini, Copilot, any of these hundreds of different LLM AI-enabled products, you probably understand that you can use them to write your code. I'm sure a lot of you use it for your assignments as well, whether your faculty likes it or not. um, but you probably have a deep understanding of the fact that typing itself doesn't get you anywhere, right? What's really important is the decisions and the stuff that needs to be made, and those decisions are not with AI. Those decisions are still with humans and with all of you, right? So that takes taste, design, judgment, all of those things. um, The second one again is on similar lines, but slightly different in the sense that yes, code doesn't matter, but outcomes do, right? And essentially, as developers, um, we're kind of seeing a shift in the industry where um, initially, especially new grad developers between experiences between 0 to 5, 0 to 6 years of experience, you would essentially the question was, can you write good code, and can you solve this technical challenge, right? However, over the last couple of months, this has shifted quite a lot. Now the question is, what value can you bring to the table? What problem are you solving, right? um, how to solve it, what code to write is something that LLMs have figured out, and they're doing it better than most of us can, right? So what really matters is to figure out what outcomes does your code actually provide. And the third one is probably the simplest, and I think it's true to probably all of 40, 50 years of computing history, that you need to compound your learning. 30 minutes a day, build with AI, build with other tools that are available. Um, the industry is shifting quite frequently. There are new things coming up quite frequently, so keep yourself updated. And yeah, that's so just these three quick mantras before we deep dive into agents, right? Um, so let's start with what exactly is an agent. Um, Let me see if I can get a show of hands. How many of you here have used a basic chat style LLM, ChatGPT, Gemini? Uh, just hit a like instead of show of hands. I think just hit a like if you've used any of these. Okay, yeah, that seems like a lot of you, right? Um, if you remember, when ChatGPT launched 2 years ago, it was essentially just a chat, right? You could send a request and you would get a response. Your request would be hi, and your response would be, hey, I'm ChatGPT, how can I help you, right? It was very simple, very, very straightforward in the sense that for every request, you get a response, right? Recently, have any of you noticed that, especially in the last about 1 year, ChatGPT can now do web searches. ChatGPT can now do stuff like creating files, accessing files, stuff like that. Now, let me ask you this: have any of you used coding tools like um, GitHub Copilot or Claude Code or Codex, or I think Google also probably has one, Gemini and stuff, right? Yeah. So seems like a lot of you have, and that is honestly great. So essentially, all of the tools are these tools are agents, right? And to define it simply is to say that when you give an LLM some superpowers, and a little bit of autonomy to figure out what it wants to do with those superpowers, that that system becomes an agent, right? So ju- that's a fairly, I would say, a fairly simple and all-encompassing definition of an agent. So pretty much any um, pretty much any access you have to LLMs today is to actually an LLM system, and that LLM system is the agent, right? Now let's see if we can, yeah, let's look at the agentic loop. Um, so as I said, right, initially, there really wasn't a loop, right? All you had was user sending a request and LLM sending back a response. Now you have a little bit of difference, right? Now you have the react loop, which is reasoning and action loop. So the user sends some request, right? Whatever, some request with some information saying, hey, you have access to tool A, tool B, tool C. And a tool is essentially, it could be anything, right? It could be a function, it could be uh, if your agent is running on your local laptop, it could be your shell commands or terminal commands or anything else, right? But essentially, a tool just being some way to execute something in the older legacy computing world, right? So uh, user sends a request to the LLM. LLM decides if it wants to use any of the tools that are available to it, right? Now the LLM is going to send a response back to the user saying, hey, can you run this tool for me? The user runs this tool and gets an observation. An observation is basically just the result of the tool, right? So if you write a function, you send in some arguments, some parameters, and you get some output, right? And the observation is basically the output. Now you feed back this observation, you feed it back into the LLM. So now the LLM has the original context of your question or query, and then it also has the context of its decision to call this tool. And now it, in the third part, it also has the result of it, right? So with these three things, the LLM is now going to reason again upon it and say, and figure out if it needs more information to do its job, more tool calls to do its job, or it can respond to you, right? Now, it will keep running this loop until the LLM is satisfied that it has enough information to to do what to do its job, right? And once it's done, it says, "Hey, I'm done, and here's here's everything that you needed to answer the query," right? And that's when the loop kind of ends. So this loop again is called the reasoning action loop, so react. And the core model is basically three things: your LLM model, your tools, and your control loop. For those of you who are, I would say, AI pilled, in that sense, for those of you in that AI pilled category, you've probably heard of people talking about what is this AI harness, right? And people talking about, hey, we need a coding harness, we need an AI harness to access the real world. You might have heard terms like that, right? So the AI harness is basically just this, the agentic loop, right? So the agentic loop with some decoration around it is essentially what a harness is. All right. So let me just give you a quick summary of what we'll try to build today. Um, Step one is just going to be a plain LLM call. So very similar to the older ChatGPT, the original one, where you get a request, you send a request, you get a response. That's it, right? Step two is probably just to give it one ability, right? One or two abilities, and see what it can do with that ability. Step three is where we start turning this into a loop. So you get the output from the first tool call, and then you send it back. you see if you get a new response or a new tool call request and stuff like that. Originally, I did have um, a fourth one, which was basically just a chat. So on your terminal, you would be able to kind of run your own chat, right, with your own API keys. But I don't know if we'll have the time for that. So let's see. Um, all right. So yeah, this is a crucial part. Before we get into the coding stage, let's do a setup check. Um, do all of you have Python installed on your local machines? Okay, that I see hands. Anybody who does not have it? Okay, so raise your hand if you don't have it. Uh, okay, I don't see any raised hands. That's great. Um, do all of you have the API key from AI Studio? Perfect. Raise your hand if you don't have it. Okay, I see a couple of them. So let's see. Let me stop sharing my screen. Give me a second. So in the chat, I've pasted a link to the API key, which is aistudio.google.com/API keys. And let's see. Yeah, and that will take you to um, the Google AI Studio website. And you can create an API key here. If there's already a project, you can use it. If there's no project, just create one. Takes about a minute. And then click on create key. This does not require you to pay at all. It's completely free. So everything we're using today is free. So you don't really have to add your credit card information or anything like that. So okay. For those of you who do not have the API key, I'm just going to halt for a second while you get it. And whoever does not have an API key, can you please raise your hand again? I just want to see how many people I'm waiting on. Okay, so just two people. That's great. Okay, so about five people. Okay, that's pretty good. Um, once you get the API key, um, just save it in a text file in your local machine. And do all of you have VS Code? VS Code or any editor, Sublime Text, VS Code, anything. Okay, seems like that's the most. Okay, that's great. Um, let's start with, in the chat. I think I have a pinned message with code download, right? Can all of you just click on that and download the code? Um, if you're familiar with GitHub, I also have a GitHub link. You can just clone my repository. Let me, yeah. So this is, I don't know if you can see it, probably not. Yeah. So for those of you who are familiar with GitHub, this is the repository. You can just clone it. For those of you who are not familiar with GitHub, I think two things. Number one, get familiar at some point, not right now, but you can download the code here, right, in a zip file. So, okay. All right, so I'm just going to halt here for about 2 minutes, about a minute or two. What I'd like for everyone to do is number one, download the code. Number two, open a terminal and go to that folder, right? If it's a zip file, just extract those files and then go into that folder. Um, Just give me a thumbs up when you have a terminal which is pointing to that folder. Okay, that's yeah. I see this guy Amay. Yeah, lots of thumbs up, Amay. Nice. Uh, all right. So I'm just going to get my um, I'm just going to turn off my video for a second. Wait for a minute, and then we'll start again. All right. Anybody who has not downloaded the code yet, raise your hands. Okay. Yep. So we're waiting on a few people. Um, Go ahead. I'm just wait. I'll probably give you another 30 seconds, about a minute. Um, okay. Can you all see my screen? You should be seeing my terminal at this point. Okay, that's great. Okay, cool. So give me a thumbs up if you have Python installed, you have a terminal open in the folder, and you have VS Code installed. Okay. Um, and I'm assuming all of you have an API key. So let's do a bit of setup first, right? Um, Go into your .env file. You probably don't have an env file, so you probably have a .env.example file. Just copy this into a .env file. Just duplicate this, create a new .environment file, and just paste this. Oops. Never share your API keys. So anyway, this is your API key. I have star 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 here, but what it should actually be is the API key. So let me know once you've pasted your API keys into the environment files. Let's see. Okay. Few of you. Yeah. So you need to paste it here. Right. All right. Now let's quickly run requirements.txt. We have two requirements, three requirements, Python.environment, Google Gen AI, DDGS is DuckDuckGo SDK. DuckDuckGo is a browser search agent like Google or Bing. Right? Now, open your terminal. Here's my terminal. Wait, this is the wrong terminal. Yeah. So yeah, here's my terminal. Open it. Just run pip install. Yeah. So the command is pip install -r requirements.txt. This is going to install these requirements into your local folder. Let me. I see a few raised hands. Go on
Uh,
if you have.
Hi Mayuresh. Actually, it would be great if you could like increase the font size for the code editor or the terminal, so others could
Oh,
view it.
right.
Yeah.
Yeah.
Th-
Is this better?
Yeah, that's better. Thank you.
Yeah. Okay. So once your requirements are installed, we are actually going to run a quick test. And the test is to basically just run the first Python script. So we'll say Python step one. Yeah. So you should be able to run this. And if it doesn't run, then there's something wrong with the setup. So go ahead, run your Python step one llm.py and um, give me a show of hands if you face some issue with that, so any kind of errors. Yeah. So yeah, you'll see some output. Essentially, if you don't see any errors, you're fine, right? Okay. I hope I didn't miss any hands. I don't see any hands, so I'm assuming all of you are able to run the step one llm.py. Just give me a thumbs up, just so I know if. Okay, lots of thumbs up. I see a raised hand. Vikrant, if you're stuck, just yeah. What error are you facing? Yeah, um, you need the you need this, right? You need to type in Gemini API key and then equal to, and then instead of these stars, just replace these stars with your specific API key, and then try to run it. Have you done that already? Mm, okay, so that seems weird. Shouldn't be an issue, but interesting. Okay, yeah, I think I'm just going to continue because there's there's a lot of other folks who are able to do it. But yeah, I'll probably work with you if you still have an issue, Vikrant, towards the end of the session. I also see a chat saying, "Can you send all the setup process PDF?" Yes, I. Oh, is everyone not able to hear me, or is it just a few of you? Can I get a show of hands if you can hear me?
You're audible, sir. Probably some people are having problem.
Okay, yeah, that's acceptable, I think. Great. Um, okay, so yeah, I'll definitely send over any setup files. You have all the code files, and there is also a recording we are doing for this, so that will also be shared with you. So hopefully, if anyone does actually face any issues in between, they should be able to cover up later. All right, so yeah, if you have this running, then your setup is basically. So let's do a quick look at what exactly are we doing in this first llm.py file. Um, so I'm doing a bunch of imports. Essentially, most of them are not important. The only important one is this Google. We are importing GenAI from Google. Um, so I'm just going to do a quick walkthrough of what exactly we do in this file, right? Whatever Python file, Python code you ran, what actually happened. So we created a GenAI client. This is a client which is just going to send your API requests to Gemini, right? The only advantage you get by using this is you don't have to write your own REST API requests. You can rely on the SDK to do that for you. You can select multiple different models. Let's see if I can show you. There's all kinds of models. So you have Gemma 4, Gemini 2.5. You have like all of these hundreds of different models, right? You can pick any one. For this specific session, I would recommend sticking to Gemma 431 billion parameter model, just because it has relatively acceptable free tier user limits. So hopefully you shouldn't get stuck with anything if we use this during our session today. So the default model we are using is Gemma 4. Now you're doing something very simple, right? You're just saying model.generate content. You give it the model, you give it your first prompt, right? Your first prompt is the content. In one sentence, what is a React pattern? I'm just going to run this while we wait for the output, right? And you print the output from this simple API call. In the second one, we are doing the same thing, but what we are asking the LLM for is different, right? Here you're asking it a knowledge-based question. In the second one, you're actually asking it a fact-based question, right? So there's a difference. Microsoft stock price is something that changes every day, and if the model does not have access to internet or does not have access to the correct tools, it doesn't have a way to actually know this, right? So it should do one of two things. It can either reject the answer or it can just lie to you, right? So let's see what it does. For the first one, it's a knowledge-based question, probably in its training data set, so it knows about the React pattern, right? The second one is here. As of the most recent market data, October 24, 2024, Microsoft stock price is around 424. Now, here it has given you partial information. This information is what you call a hallucination. I'm sure a lot of you have heard of this term hallucination. So what exactly is a hallucination? This is it. The model will lie to you very confidently, and it makes you think that the model knows what it's talking about, but that's not necessarily true. There is no reason to believe that on October 24, 2024, this was the stock price. It is a blatant lie, right? But it's a very confident one. So hallucination is a big problem with any of these LLM AI systems, agentic systems. But yeah, we'll figure out how to deal with that. Then it does some calculation, which again may or may not be right. And finally, you kind of end the response, right? Any questions? I'm just going to take a quick halt here, see if there's any questions. Okay, I don't see any questions. Great. So here we've done only two things, right? Just send a request with a prompt, send a request with a prompt, get a decent answer, get a blatant lie. Two different things, right? Now the next step is to actually avoid this hallucination, giving it access to a tool, right? So if I could give my model access to a web browser, or let's say Google or Bing, right? It could go ahead and try to search for the Microsoft stock price today, right? And maybe it will get an answer there. So we don't know. We can give it a try, right? So yeah, just open this next file, which is step 2. So there are two files, step 2 tools, and then step 2 tools to do. Tools is the one which will work for sure. To do is the one that I would expect a little bit of hands-on. Let's see if you can write a little bit of Python code. I've mostly done a lot of boilerplate here, but yeah, I'll point you to specifics where you need to add a little bit of code. So essentially here we are doing the same thing, just importing Google Gen AI, Google Gen AI. Now, here's two different things, right? One is how we call the model is going to change a little bit, but also what we call the model with, right? So now we are going to pass two functions to the model. We are going to pass a web search function and a calculator function. Now, I've already done the web search function, so it's fairly simple, right? This is the DuckDuckGo SDK, and you give it a search query, and it gives you some number of results. We set it to 5, which is basically just some text, right? And for each of the results, you get the body of the results, append it into like a massive string, and just return that, right? So the return from web search is basically the body of the top 5 search results for that query. Now, because this is already done, you don't really have to do anything here. The next one is a simple calculator, right? The calculator takes in a string expression and returns a string output. Essentially, just evaluate any basic math operation, anything, multiplication, division, the simple addition, subtraction, multiplication, division, right? So we allow a certain set of characters in the string, and then we validate that, and then we do some calculation. I'm going to halt here for a second. Yeah, I would just expect that. Why don't you guys give it a try? Just write down just write down how you will evaluate a string expression in Python. Right? Just take 30 seconds. Quickly see if you're able to do that. Anybody want to paste their solution in the chat? Okay, and that doesn't seem like it. Yeah, people seem to be tired. So okay, essentially this is pretty simple. You can just evaluate the expression, right? Oh, come on. Right? But this is going to return some kind of numeric value, but you want to return a string value, right? So you just convert that to a string. Right? And that's it. That's your calculator. So we save this. Okay. Just give me a like if you're following through. If many of you are stuck, then we can address those issues. Okay, I see lots of follow-throughs. That's great. Okay, cool. So yeah, so essentially what we've done is we've defined a web search, we've defined a calculator, and now we need to figure out how to use these methods, right? So my prompt is the same as it was before, which is search for the latest Microsoft stock price, then compute a certain percentage of it, right? Now, how am I going to call my model API? So I'm still sending my model, I'm still sending my prompt, but now I'm also going to send a list of the tools I have, right? So here in the generate content config, I have the option of sending a list of tools. And what are tools? Tools are just functions, right? So I could say web search and calculator, right? That's it. It's just a list of 2 functions that I would call. Let's see. Okay. Give me a second. Yeah, I see your hands up. Is there anything I can help with? Okay, no response. Cool, no problem. Now the Google Gen AI SDK also allows you to execute these functions and do all of the fancy stuff automatically. But we have disabled this explicitly. We are going to try and build this ourselves, right? So we are only using this GenAI SDK as a request response provider. That's it, right? Um, so we call the LLM with certain tools. We call the LLM with a prompt. Now you get a response, and you need to figure out if this response has a tool call, right? A tool call is a function call. So if uh, sorry, yeah. So you can assume that a function is the zeroth function call. If the function exists, you know that the LLM wants to call a certain function or a tool, right? If it doesn't, then the LLM doesn't really want to do anything about it. It has hallucinated an answer, right? Um, so let's try to run this and see what we get. Okay, so this was my original query. And it seems like the LLM does actually want to call a tool, and the tool is web search. It wants to call this with these parameters, right? Latest stock Microsoft price. Are we following until here? Essentially, what we have done right now is um, we've told our LLM that, hey, you have the ability to run these two things, right? They're not doing it yet, but they just know about the ability to do this. That is all that step 2 was. Are you guys following me? Okay, that's a decent number of likes. Great. Perfect. Let's quickly go on to step 3. This is where, this is truly the crux of it. And considering the time, we're actually way over time, but I'm going to try and, instead of doing a to-do exercise, I'm just going to walk you through this code so that you understand what's happening, give you a quick demo, and then let's see what we can do with it. So we're basically doing the same thing, right? This is the same as step 2. You have a bunch of imports. You've basically defined your web search, you've defined a calculator, and you've defined a new function which says save report. The only job of this function is to get a file, get some content, and save that content in a file. Right? That's it. It's not doing anything else. Nothing fancy. So now you have 3 tools: web search, calculator, and save report. Right? And now you're going to try and run this. Now you're going to try and run the tool call, right? So even in the previous step 2, you saw that LLM wants to call a certain function, right? But we are not executing the function. Here we are going to execute that function. We are going to first identify which function is being called. Second, identify the parameters of that function. Third, execute that function, get the output, and then send that output back to the LLM, right? So just bear with me for a second, right? So here what we do is we create a chat. A chat is just something that allows you to do this kind of iterative work with the LLM. So you don't have to manually append the outputs explicitly. You can just use this SDK feature to do that. So the only thing it does is appending outputs one after the other. There's nothing really fancy happening here. So essentially what we've done is we've created a new chat and we've provided it a system instruction. The system instruction is basically just a set of, it's a persona, right? The persona can be anything depending on your application. If you're building a medical helper, you can probably say you are a helpful nurse or you're a helpful doctor, right? If you're building a specific application for developers, you can say you're an expert developer, right? You can give it any different kind of personas, and LLMs tend to perform better when you give them this kind of a persona beforehand. Um, m- uh, I'm not sure if many of you know, but for every chat application that you use, whether that's Gemini, ChatGPT, Copilot, all of them have a hidden system instruction. You probably don't see it. Not probably, you definitely don't see it, but there is a hidden system instruction. And this is kind of what it looks like. Obviously, much more complex, much larger. Right? So we're going to say you're a helpful research agent, use the provided tools to gather facts, do math, and save the report. So this is not your prompt, right? This is only a system instruction. Um, your prompt is, where is the prompt? Okay, it's not here. It's here. Yeah. So you're going to run the agent with this prompt, saying run agent, and then you're going to say research the top three agentic frameworks, compare them, make a short markdown table, and then save it into report.md. Right? That's your prompt. Your prompt goes into this run agent function where you create a chat, you give the chat a system instruction. Right? Now, the first thing you're going to do is send the model um, your actual user prompt, right? Because the model needs to figure out which tools to call and what to do. So you say chat.send message user prompt, right? Now, for a second, ignore this for loop and just look at this, right? You get a response from the chat. You look at, is there a function call within the response, right? Is the LLM requesting for a function call? If not, great, that's the final answer. You're done, right? But if there is a function call, then you extract the function, you extract the arguments, and then you run it, which is here, right? So this is basically the result is the output of your function call. Again, these are your function call: web search, calculator, save report, and result here is the output. Sorry, where was I? Yeah, so result here is the output. You can ignore the preview. This is just so that you don't have to dump all the text in your terminal. That's the reason there's a preview, but you can just ignore this. So you take this result and now you send this result back to your chat, right? So here you say chat.send message from this comes from a function's response, right? So you're going to say this comes from a function response. The name of the function is this, and then this is the response, right? And let's quickly do a run of this. Actually, hold on. Yeah, I canceled it. Give me a second. Yeah, just wanted to clear the terminal. So in the background, it's doing, yeah, there you go. It decided to call the web search tool with this query, right? Now, the query returned a response, which is the observation. This observation is here, like probably the first 200 characters of the observation, just so that it's not too noisy. Now you send this observation back to the LLM. The LLM decides to do a second tool call with this query. You get another observation. You send this observation back to the LLM again. And now the LLM decided it has enough information. So it's going to call the save report, save report function. And you see, I don't know if you noticed, but this report.md popped up on my on the side. So let's see what it is. Right? Yeah, it's what was my prompt? My prompt was research the top three AI agent frameworks in 2026, compare them in a short markdown table with name, maintainer, strength, best. you have the name, maintainer, strength, best for, right? Three of the top LLM frameworks. So essentially what you've done now, you've given it access to local tools, whether that is, you've given it access to both online tools as well as local tool, right? Web search is an online tool, and saving a report is a local tool. Now, you can extend this even further, right? If any of you have used Copilot, like GitHub Copilot in for coding or for doing assignments or anything like that, you've seen how it operates, right? When you ask a query, it is going to first go through your folder, right? It's going to see, can I run ls? Can I list all the files within this folder? Can I see what directories exist here, right? Can I read this one file and see if this file is important to me or not, right? So all of these tool calls are something that are now available to you, right? All you need to do is not this. Yeah, all you need to do is define a new function and just list that function here, right? That is it. That is all you need to do. And I see that we are actually way over time, but I'm just quickly going to do a final demo for you, which is this, right? I would have loved to cover this, but I don't think we'll be able to do it today. But let me just do a very quick skim through, right? Which is the final one for us was going to be a chat. So as of the step 3, you see that we are only sending a query once, right? And then something happens and you get a result. There is no interaction. With ChatGPT, Claude Code, Copilot, with all of these, there is a interactive factor, right? You get a final response from the first prompt, and then you can judge whether that is it or whether you want to do something more, and then talk to the model about it, right? So that is basically what we were going to do in the step 4, right, which is to build the chat. So we have the same tools. You have web search, calculator, save report. But essentially now everything that we did in step 3 is called a single turn, right? A single turn of agent. So anything between your prompt and the final response from the LLM is going to be called a single turn, right? So everything in step 3 is moved into this function called run turn, right? And then we run the turn in a while loop until the user actually closes it. I would recommend that if you guys have the time, definitely try to run step 4 chat and see what it looks like. I'm just going to give you a quick demo. Yeah. So this is my chat. I can say semantic kernel and Landgraph. Okay. Let's see what it comes back with. So one query regarding semantic kernel. I would expect another about Landgraph. There you go. So all of this is a single turn, right? Now it's doing a comparison between both of them. Okay. I hope it's not stuck. Oh yeah, there you go. It gave a huge set of information. Here's a detailed breakdown. There you go. Something about semantic kernel, something about Landgraph. a bit of comparison summary, right? Um, but now you have, in the step 4, you have the ability to actually continue this conversation, right? In step 3, this is where it ended. You would basically get a report, or you'd get the final response, right? But here you can see you can still continue. You can say, um, who is the founder of Landgraph, right? It's not relevant, but sure, why not? I mean, you could do this on ChatGPT, you could do this on Copilot, so why can't we do this? We definitely can, right? And now you have this conversational UI, right? There you go. Harrison Chase is the founder of LangChain. There you go, right? Um, so yeah, I think unfortunately I don't think I was able to go into as much detail as I would have liked to, just because of the time constraint. So I would say, go through all the code. Try to experiment with it as much as you can. If you have any questions, I'm always available. You can reach out to me. And finally, I would give you a take-home challenge. Today is Thursday evening. You have Friday, Saturday, Sunday, one day for party, one day for chill. One day I would expect you to just do a take-home challenge, right? Um, Pick step 3 or step 4 code and extend it. Extend it with any of these, anything that solves your problem, right? You could extend it with, can I build something that can I build an LLM tool that generates notes from my professor's slides automatically, right? Can I build an LLM that does quizzes and that yeah that does quizzes and generates test assignments for me, right? For my own learning. Can I build an LLM agent that's going to read a bunch of papers and give me a good summary of everything that's happening in that field, right? So yeah, and anything else, right? If you're a YouTuber, if you make reels, if you post your photos, make an agent that does all of this stuff for you, right? So essentially my point being, really solve either your own problems, or your friends problems, or your parents problems, or your mates problems, or your kirana wala's problems, right? Solve someone's problems using AI and LLM, because that's basically the future. And anybody who's able to figure out how to apply agentic models to the real world is the one who actually wins in the long term, right? So yeah, I would just say, try, experiment, and learn as much as you can. Nowadays there's a lot of good free APIs as well, so hopefully it's not a, a big issue to um, get tokens and stuff like that. So at least, I'm just going to stop the technical presentation here, because I know we're way over time. um, does this sound good? Well, does anybody have any questions?
Yes, Mayuresh, I must say it was such a patient, full of knowledge presentation. I'm very happy with the way it was all carried out and supported by our team and enthusiastically participated by our participants. Guys, we will have one more session from Mayuresh. In fact, many more such sessions from Mayuresh soon because of today's lack of time and delayed start. We couldn't cover as much as we wanted. Now, a query session, guys. If you have any other query other than the technical one, you can please ask him. Mayuresh, but do you have time of 10 minutes?
Yeah, I do have time. I'm okay.
Okay, okay. So participants will be sharing this video soon. It will be online on video YouTube, and it will be shared to you soon. In the now Once we come to the end of this session, I would like the participants to ask any non-technical questions. There are so many questions in today's youth's mind. You can go ahead, guys.
Yeah, just raise your hand and then ask your question.
Okay, Mayuresh, on the
Yes.
okay, who is talking?
No, no, sorry, that was me. Yeah.
Okay, so Mayuresh, on behalf of my participants, I would like to ask you one question. There
Mhm.
is a fear in everybody's mind in today's era of AI that how to survive in this world. When experienced people are facing problems of survival, freshers are even more fearful. So, what
Yeah.
advice would you like to give to them to prepare themselves
Yeah.
for the job
Yeah.
market?
I think I have two very specific advices for that.
Okay.
The first one is, as I said, um, what really matters now is how you use AI in your domain, right?
Hmm.
So if you're a computer science student, how are you using AI to do things in computer science? If you're a mechanical engineer, it applies to you as well. If you're doing anything, right? Even if you're just typing on your keyboard, it's going to make a difference if you're able to figure out how to use AI and LLMs to increase your own productivity, give better outputs, and really generate value, right? Um, but there's also another part to it, right? While all of us are building these new skills, there is definitely some truth to the fact that markets are not going to be as good as they were earlier. Um, I would say for computer science students, the last 2 decades were probably the high point, and we are definitely going to a point where there will be fewer computer science jobs. That said, let me just give you this one example, right? Today in Silicon Valley, the highest paid engineers last year, the highest paid engineers earned um, about a couple of $1 million at a minimum, right? And who hired these engineers, right? That's the interesting question. These engineers were hired by OpenAI, Anthropic, Meta, Microsoft, all of these, right? And where and why? So they were hired because there is a real need for good engineering talent, right? The only challenge now is that because of AI and LLMs, each engineer is 10 times, 20 times more productive, right? So you're obviously going to need lesser number of engineers. So the challenge for all the students is really um, to excel. And I actually have a pretty good slide about it. Let me just do a quick presentation. Let's see. Yeah, this is it, right? Be T-shaped. So this is advice I got when I was in university. This is advice I'm giving you now 10 years later, right? And it's the same advice, which is pick a single vertical, right? You need breadth in everything, which is you need to know a little bit about how backend works, how ML works, how security works, all of that, right? But you pick one specific area of depth. If you're a front end engineer, if that is what excites you, be the best damn front end engineer you can, right? If you are a backend engineer, be the best one you can. And in the next 5 years, you'll probably see this that um, I mean, I don't want to sound all doom and gloom, but it is a fact, right? Where you will see a distribution. Like currently, there's a straight line, right? Lower level of talent, lower level of pay, higher level of talent, higher level of pay. Um, and there's a very clear distribution amongst that. But in the next 2 to 5 years, you will see a stark differentiation between people who truly excel at their fields, right? And those are the people who are actually, it's like doctors and surgeons, right? India's best surgeon is obviously going to be doing a lot better than any average person, any average doctor, right? Very much like that. So I think the only advice I'll give you is truly excel at what you do. Pick a domain and truly excel at it, right? And especially if you're a third or a fourth year student, I mean, for first and second year students, I would say breadth is a lot more important. But if you're a third and fourth year student, it's really time to start figuring out what your depth is going to be, right? And if you're a third year student, you should already have figured it out, or you should be finalizing what you're going to really do, and then spend 6 months to 1 year to actually be the industry expert there, right? There should not be any difference between you who's graduating from university and anybody with 5 or 10 years of experience. You have all the knowledge that's available, you have all the tools that are available, all you need is a laptop, right? So there is no excuse for you to not have that level of proficiency. And the fact is, we do see this level of proficiency with a lot of people, and these are the people who are actually going to do well. So I just I just want to say, push yourself to excellence as much as you can, because that is kind of what's going to be valued. I'm sorry if it was a long answer.
Thank you so much, sir. There are a few queries in the chat box.
Yeah, let's see. Yeah, I'll answer these sooner. Um, mm, okay, I see. Uh, okay, I see one from Aditya. I'm studying data science, but I get to hear a lot that this branch will be wiped out. Absolutely not. Data scientists are actually the bread and butter of companies right now. What software engineers were for the last 2 decades, data scientists are going to be today. At the end of the day, an LLM eats data for breakfast, right? And without data scientists, not happening. So yeah, data scientists are good for the long term. Don't worry about it. Manasi has a question. As an AI and data scientist student, I just have a question. While AI streams are in high demand and have the best salaries, what abilities do companies prioritize? I think companies still prioritize the same thing that they did before, which is in your specific domain, right? Like if you're a data scientist in your specific domain, how well can you do, right? And a lot of things um, that were considered as that were not expected of a new grad student are now expected of them, right? So just as an example, right? When I was in university, you could if you could do lead code medium and lead code hard, you could get a job, right? Today that's not the case. You need to do lead code medium, lead code hard. You also need to do a bit of system design. You need to do a bunch of other things, right? So at least with respect to AI, nothing has changed for like, companies are still looking for the same abilities. They're just expecting you to be AI native, right? They expect you to be able to do the same things 10x better, 10x more productively, with the use of AI, right? So think of AI as a tool that you have, right? So an example that I like to give is, think of yourself as a carpenter, or uh, a carpenter who knows how to make a great piece of dining table from teak wood, right? If you give him power tools, he's going to do that much faster. But the carpenter still needs to know how to make that table, right? You can't you can't ask a plumber to do that, right? So your core set of skills are still important. LLMs are just power tools that get you there faster. I see two more questions. Okay. Sir, I'm studying in ENTC, so what could be safer side, either to go into hardware or else choose software? Well, that is actually an interesting question. If you asked me this 2 years ago, I would have said go into software no matter what, right? Because what you see in the industry is hardware folks, however talented, have fewer opportunities. That was true 2 years ago. But today, the hardware market has changed drastically, right? The largest company today is NVIDIA. There are hundreds of startups, hardware startups, that are actually competing with NVIDIA in the space of LLM inference and LLM training. AMD is competing with competing for LLM training. You have essentially, the point being, today hardware is a bottleneck. and there is a massive demand for hardware. So today I would say it's a great time to get into the hardware industry, because hardware industry is going to see a massive growth over the next 2 to 5 years. So the more an industry grows, that much more your career also grows. So yeah, it's a good time to do that. I see a few more. Okay, let me just answer these quickly. What would you recommend for those who are in core branches? You're in first year electrical engineering. How can you integrate it? Okay, let me give you an example. First year electrical, first year mechanical. I don't know if if you're exposed to tools, but generally, even for electrical and mechanical and any of these core branches, by your third, fourth year, you are going to be using tools like AutoCAD. For electrical, there are modeling tools that do Fourier transforms and stuff like that. So all of these tools are available, right? And you are taught to use these tools. You need to figure out, how can I use AI to use these tools, right? So if you want to do some kind of a Fourier transform on to figure out here what my power distribution is going to look like, um, it's probably a good idea to start figuring out how to use AI, right? And AI, you could ask these questions to AI as well. And a lot of these companies are also figuring out how to integrate AI directly into their products. So you'd have like a chat GPT kind of chat within the tool itself, and you can ask the tool to um, build something for you, and the tool does that in the software. So yeah, there's definitely a lot of good ways to do integrations even for core engineering. And I would bet that for core engineers, if you are able to do that, the value is significantly higher. Because for CS and like for computer science EC students, it's probably it's expected that you'll do it. But for core engineering, if you do it, that's a massive plus point. And what should a student pursuing bachelor's in AI data science focus to build a strong profile for top AI MS programs like CMU? There's only one answer for this: research, research, research. Get yourself out there, do as much research as you can. And see, the thing about research, which very few people tell you about in university, is breadth of research matters. So do research, start by doing research with professors in your own university, right? That is the best starting point. Then do internships, do summer internships, do winter internships with universities elsewhere, right? So that gives you exposure to what other people in the same field are doing, right? And so yeah, do great research, and that is your best way to get into any of these top AI programs. So yeah. um, I see. Okay, I think this is. I see there's a bunch of other questions. I'll probably answer them offline, but I'll probably just take one. What is the one problem you're currently working on that didn't even exist 3 to 4 years ago? Oh, this is a good one. AI evaluations. AI evaluations didn't. I mean, they existed, but in research circles, they did not exist in in production systems, right? I mostly work on large scale systems, production systems, stuff like that. My exposure to research is very limited. So the one thing that has changed for me is now AI evaluations are the next big thing, in the sense that an LLM is going to give you an output. But if you notice, um, for 10 different sessions, if you ask the same question, the LLM is going to give you different outputs, right? So how do you judge the quality of output for an LLM? For an API, it's very easy. If I get a 200 okay response, I know it's working. If I get 500, I know there's some server error, right? But for LLM, this measurement of quality itself is a massive challenge. And the more you use AI and LLMs, that much more it's difficult to judge the quality of outputs, especially in production systems. So yeah, that's kind of something that's new in the last 3 to 4 years. So yeah, I think there's a few other questions, but yeah, I'll probably take them offline.
Thank you,
Okay.
Mayuresh.
Yeah.
Okay. So thank you so much, Mayuresh, for your valuable time and answering these many queries so patiently. And you will be answering many more offline also. Here we conclude. We are coming to the end of this session. Guys, this video recording will be shared to you. And over to Zui now.
Yes, on behalf of MMIT and IEEE Student Branch, I sincerely thank our speaker, Mr. Mayuresh Waykole, for such an insightful and engaging session on building an AI agent. I extend my gratitude to Dr. Rupesh Bhotake, the principal of MMIT, Dr. Subhash Rathod, sir, HOD of Computer Engineering Department and Treasurer of JCT's TS IEEE Pune section. Dr. Neha Sharma, Chair of JCTS IEEE Pune section, and Dr. Monica Dangore, IEEE Student Branch Counselor and Vice Chair, IEEE Pune section, for their constant support and guidance. I would also like to thank all the participants for their enthusiastic participation and the organization team for their dedicated efforts. We look forward to more such sessions in the future. Kindly fill out the feedback form and mark your attendance.
Thank you so much, Mayuresh. Thank you so much, participants. Yes, sir.
Yeah, I was just going to say thank you so much to everyone for
Yes.
being patient with me and staying up late for this session. Really appreciate the time and effort everybody put in. Thank you so much. And a special thanks to Dr. Dangore as well for
Thank you.
hosting me here. Thank you so much.
Now you will be having office, I guess, Mayuresh.
Yes, yes, yeah, I'll be
Yeah.
heading to
So
office.
please go ahead. Thank you so much for your time. We'll be
Yeah,
ending here. We'll be stopping here, participants. Thank you so much for joining. Thank you, sir.
thank you so much. Bye.
Bye. Everybody, please fill up the feedback form. And thank you so much, guys, for being patient. It was a delayed session due to technical problem, but now we all are happy that it happened properly. Thank you so much for joining. And one more announcement I want to make. In May month also, we'll be having one more Microsoft speaker uh, talking to us on a different technology. Thank you so much for joining. I hope to see you in the next Microsoft session. Thank you so much. See you.